Okay, so before I tell you about abstract nonsense, I have to tell you some regular nonsense, which is going to be in the form of an anecdote. So last week I was playing a board game with my friends, and we were playing this board game up the top. It's kind of a simple game. You start with a rectangular grid, and players take turns placing dominoes into this grid until you can't play anymore, and then the last player who could play wins. And we were kind of playing this game, we were discussing strategies. It turned out to be more complicated than we thought it would be. And then one of my friends, who actually studies board games, came up to me and was like, hey, whenever you play these kind of games, the entire structure of the game is secretly encoded in this second game called NIM, which is much simpler. This game is just you start with a pile of objects, in this case leaves, and you take turns removing them until there's none left. And every move you do in this kind of more complicated game is really a more complex version. The shadow is like a simpler move in this easier game that's much more reasonable to understand. And this reminded me of something that came up in my research. So I was studying the 15 puzzle, which is this 4x4 grid labeled 1 to 15, and because of the missing box you can kind of slide the pieces around. And it turns out that certain configurations I was interested in of this puzzle correspond to really well understood transformations of some 24,000-ish dimensional space. And by some mathematical irony, the 24,000 dimensional space is actually way easier to study than this thing. And so this adage, kind of especially in modern mathematics, comes up time and time again, which is when you want to study some objects, you don't look at each object individually, you look at the structure of the objects as a whole. So instead of studying each game by itself, you look at how the structure of all games relates to each other. And then in category theory, which is the kind of math that I do, that other mathematicians call abstract nonsense, kind of jokingly, and things that Emily Riel does, who I pictured over here, you take, for example, the structure of all games, or the structure of all higher dimensional spaces as an object themselves, and then you study the structure on those structures. Or you study the structure on the structure of structures, and the structure on, and so on, literally forever. And this idea is really powerful. It comes up a lot in linguistics, comes up a lot in philosophy, for maybe obvious reasons, comes up a lot in computer science, but hopefully I can give you some appreciation of why we actually call this abstract nonsense. All right, thank you.